Distillation process is an operation whereby the components of a liquid mixture are being separated by boiling because of their differences in vapor pressure. In other words, distillation process is a process of separating the components or substances from a liquid mixture by selective evaporation process and condensation process. We know that evaporation process is an endothermic process, which is absorb heat in order to change between liquid phase to vapor phase, and condensation is an exothermic process where release heat in order to change between the vapor phase to the liquid phase. So evaporation is working by increasing the temperature, whereas the condensation is working by reducing the temperature. There are two results from distillation process. The first one is called a complete separation, whereby the pure components is being resulted from the distillation process. The second division or the second result is called as a partial separation, whereas the increases the concentration of the selected component of a mixture. For the industrial chemistry, distillation is a unit operation of practically importance because it is a physical separation process and not chemical reaction. Normally, distillation process is called as a flash drum. As an application, there are several chemical-based applications in industry. The first one is fossil fuel industry, which is the obtaining of materials from crude oil for fuels and chemical feedstocks. The second one is industrial use, which is the separation of air into its components such as oxygen, nitrogen, and argon gases. This is the lab scale of distillation process for experiment. This distillation process can be transformed to the schematic diagram as shown here. The raw material is being fed to distillation column that consists of liquid mixture. The distillation column is working based on different vapor pressure and boiling point. The lower boiling point will be leaving the top stream of the distillation column in a vapor phase, while the higher boiling point will be leaving the distillation column at the bottom stream in a liquid phase. Now we move to the fractional distillation. Fractional distillation is the separation of a mixture into its component parts or fraction. Chemical compounds are separated by heating them to a temperature at which one or more fractions of the mixture will vaporize. It uses distillation to fractionate. Generally, the component parts have boiling points that differ by less than 25 degrees Celsius or 45 degrees Fahrenheit from each other under a pressure of 1 atm. If the difference in boiling point is greater than 25 degrees Celsius, a simple distillation is typically used. You may see here the schematic of continuous binary fractional distillation tower. A binary distillation separates a feed mixture stream into two fractions. The first one is called as one distillate and the second one is called as bottom liquid. In the large scale industrial tower, the use of reflux to achieve more complete separation of product. Reflux is referring to the portion of the condensed overhead liquid product from a distillation or fractionation tower that is returned back to the upper part of the liquid as shown here. Inside the tower, the reflux liquid will be flowing downwards, provides the cooling effect that needed to condense the vapor that flowing upwards. Like this. Thereby, this will affect the the increasing of the effectiveness of the distillation tower. The more reflux provided, the better the tower separation of lower boiling material from higher boiling materials. Alternatively, the more reflux provided for a given desired separation, the fewer the theoretical plates are required. The theoretical plates is represented by this, the black tray here. The design of industrial distillation column is shown here. The design and operation of a distillation column depends on the feed and the desired product. Given a simple binary component feed, analytical methods such as McCabe-Thiele method and the Fesquet equation can be applied. For a multi-component feed, simulation models are used for both design and operation. Alright, so you may see here, okay, the cross-sectional diagram of a binary fractional distillation tower with bubble cap tray. Alright, based on this schematic diagram, the reflux, okay, will be condensed, overhead, liquid product from distillation or fractionation tower here. Okay, as the upper part, okay, return back to the distillation column as a reflux. Inside this tower, the reflux will be downflowing that provides the cooling effect, okay, to the upflowing vapor. The upflowing vapor is coming at the bottom part here from reboiler. So, based on this schematic diagram, it shows that the more reflux is provided for a given numbers of theoretical plates, like here, the better the tower separation of lower boiling material from higher boiling materials. Based on the working principle of fractional distillation, we can say that the used reflux at the fractional distillation tower is installed in order to achieve more efficient separation of product. Reflux is referring to the portion of the condensed overhead liquid product from a distillation tower that is returned to the upper part of the tower. This downloading reflux liquid will provide the cooling effect and the partial condensation of the upflowing vapor that coming from the reboiler. Then, it can also say that the function of reflux will increase the efficiency of the distillation tower. The more reflux is provided, the better is the tower separation of the lower boiling from the higher boiling components of the feed. Flash vaporizer or flash distillation. Flash vaporizer is a partial vapor that occurs when a saturated liquid stream undergoes a reduction in pressure by passing through a throttling valve or other throttling valve that has the difference pressure. This is one of the simplest unit operation in chemical-based engineering industry. If the throttling valve or device is located at the entry into a pressure vessel so that the flash evaporation occurs within the vessel is called as flash drum. If the saturated liquid, the single component liquid, a part of liquid immediately flash into vapor. Thus, both the vapor and the residual liquid are cooled to the saturation temperature of the liquid at the reduced pressure is referred to as auto-refrigeration. This is the basis of conventional vapor compression refrigeration. This process involves of heat and energy balances. As an application, the recovery of water from seawater. A typical flash drum is shown here. A typical flash drum consists of three main components. The first one is the entrainment mesh pad that been installed at the upper side of the flash drum. The second and the most important part is inlet diffuser and distributor. And the third main component is liquid level control valve. A schematic diagram of the flash evaporator is presented. There are two possibilities of the phenomena occurs by using flash evaporator. The first phenomena, if the saturated liquid is a single component liquid such as propane or liquid ammonia, a part of the liquid will be immediately flashed into the vapor, and the vapor will be removing as a product at the top stream, and the remaining liquid will be leaving the flash evaporator at the bottom side. Both of the vapor and the residual liquid are cooled to the saturation temperature of the liquid at the reduced pressure. And this phenomena is often referred to as auto-refrigeration and is the basis of most conventional vapor compression refrigeration system. The second phenomena, if the saturated liquid consists of multi-components, meaning that it consists of two or more components in a liquid mixture. For example, a mixture of propane, isobutane, and normal butane. The flash vapor is richer in the more volatile component and will be remaining as a vapor and leaving at the upper side of the flash evaporator. And the remaining liquid, which is the the less volatile component, will be leaving as a liquid at the bottom side of the flash evaporator. The uncontrolled flash evaporator can result in a boiling liquid expanding vapor explosion. Now we go to evaporator. Evaporator is a device in a process used to turn the liquid form of a chemical substance into its gaseous or vapor form. The liquid is evaporated or vaporized into a gas form of the targeted substance in that process. The heating mechanism will withdraw the water from the raw material and be vaporized to form a gases or vapor form. How an evaporator works? The solution containing the desired product is fed into the evaporator and passes across a heat source. Then it can say that the evaporator is involving the heat and energy balance. The applied heat converts the water in the solution into vapor. The vapor is removed from the rest of the solution and is condensed, while the now concentrated solution is either fed into a second evaporator or is removed. The evaporator, as a machine, generally consists of four sections. The heating section contains of heating medium, which can vary. Steam is fed into this heating medium. The most common medium consists of parallel tube, but others have plates or coils, typically made from copper or aluminium. The concentrating and separating section will remove the vapor that been produced from the solution. The condenser will condense the separated vapor, then the vacuum or pump will provide pressure to increase the circulation process. There are many types of evaporators is being used in the industry and used today. There are vacuum evaporator and climbing film evaporator. The application of evaporators is widely used in the chemical-based engineering application, such as evaporation of water from a solution of urea and water, and evaporation of seawater to get a pure water, so-called desalination process. Alright, so the picture show the vacuum evaporator, and the second picture is the example of the climbing film evaporator used in industry. What is the difference between distillation process and evaporation process? Based on the schematic diagram here, evaporation is the method of turning liquid into gas by adding heat to the liquid so that the molecules on the surface will quickly transform into a gas form. While distillation process is a method of producing liquid vapor or steam. This is done by heating the liquid to acquire gas and then, for various reasons, condensing the obtained gas into the appropriate liquid form. Evaporation is a slow and gradual process, while distillation process is a quick and rapid process. Evaporation occurs at the surface. Distillation doesn't only occur at the surface. Evaporation is not a separation technique, while distillation is one of a separation technique. For evaporation, no formation of liquid bubbles at the boiling point, whilst for distillation, the formation of liquid bubbles at the boiling point is occurred. Finally, for evaporation, the liquid vaporization is occurred below the boiling point, while for distillation process, the liquid vaporization is occurred at the boiling point. Now we move to the drying process. What is drying process? Drying process is a process where volatile liquid, usually water, are removed from processed materials and other substances, and can also used to refer to the removal of other organic liquid, such as benzene or organic solvent from solid. Drying is, in another word, is referred to a mass transfer process that consists of the removal of water or another solvent by evaporation from a solid, semi-solid, or liquid. Many of the types of equipment and calculation methods discussed for removal of water can also be applied to discuss about removing of organic liquid. The schematic diagram of the drying process is shown here. The wet raw material is being fed to the dryer. After some time, the extra moisture content will be removing as the upper part, and the dried product will be leaving at the bottom side. The removal of water from solid materials is done through the heating process. This drying process is often used as a final production step before selling or packaging product. To be considered as a dry, the final product must be formed in solid, whether in the form of continuous sheet such as paper, long pieces such as wood, particles such as cereal grains or cornflakes, or in powder form such as sand, salt, washing powder, or milk powder. A source of heat and an agent to remove the vapor produced by the process are often involved. This process involving the heat and energy balance. The application of drying process such as drying of clothes, process of making dry salted fish, food preservation, soap powder, and dye stuff. What is the differences between drying and evaporation process? We go to drying first. Drying is a removal of relatively small amounts of water from material. Water is removed as a vapor by air or ambient. For example, freeze drying process by hot air, as shown here. Now we go to evaporation process. As compared to drying process, evaporation is about removing of relatively large amount of water from material. Water is removed as vapor at its boiling point, rather than by air at atmosphere. For example, solid purification from a solution, for example, is shown here. The moisture content of the final dried product varies depending upon the type of product. The first example is dried salt, only contains about 0.5% of water. The second is called as coal. The coal is only contains about 4% of water. Coal is classified as a non-food product. Among the non-food products, some of those that require considerable drying are wood, as part of timber process, paper, flax, and washing powder. The wood and also the paper, owing to their organic origins, may develop mold if insufficiently dried. Another benefit of drying is a reduction in volume and weight. The third example is a food product. The food product is normally contains about 5% of water in order to preserve the flavor and the nutrition. The dried food can be stored for extended the period of time. Foods are dried to inhibit microbial development and quality decay. However, the extent of drying depends on product and use. Cereal and oilseeds, for example, are dried after harvest to the moisture content that allows microbial stability during storage. Vegetables are blanched before drying in order to avoid rapid darkening, and drying is not only carried out to inhibit microbial growth but also to avoid browning during storage. By concerning dried fruit, the reduction of moisture acts in combination with its acid and sugar contents to provide protection against microbial growth. Products such as milk powder must be dried to very low moisture content in order to avoid any caking. This moisture is lower than that required to ensure inhibition to microbial development. The other products, such as crackers, are dried beyond the microbial growth threshold to confer a crispy texture, which is liked by consumers. The final is microorganism. Microorganism is inactive as the water content is reduced below about 10%. The additional information about the sludge and fecal material from sanitation processes. In the area of sanitation, the drying of sewage sludge from sewage treatment plants, fecal sludge, or feces collected in urine diverting dry toilets, or be shortened as UDGT, is a common method to achieve pathogen kills, as pathogens can only tolerate a certain dryness level. In addition, drying is required as a process step if the excreta waste material are meant to be incinerated. The equipment for drying are shown here. The first one is tray dryer. The second one is using the vacuum, as called as vacuum shelf indirect dryer. The third is continuous tunnel dryer, is a long shape. The fourth is a rotary dryer, is circular dryer. Same as drum dryer, is also made as a circular development, and the most commonly being used in university lab is a spray dryer. Now we go to the sublimation process. Sublimation process is a phase transition in which the gas turns into solid without passing through the liquid state. It is the reverse of sublimation. If you can see from the schematic diagram here, the raw material is being fed as a gas or vapor form. After some time, the successful transformation of gas or vapor will directly be formed to solid product, and the unsuccessful of gas and vapor will still be remain and removing from the unit operation in the gas and vapor form. This sublimation also called as a deposition process. For this sublimation to occur, the thermal energy must be removed from a gas. The gas or vapor being transformed to the solid phase through the heating mechanism. This is how the snow forms in clouds and how frost and hoarfrost form on the ground or on the windows. This process involving the heat and energy balance, and the types of heat is exothermic process, or the heat is being released from the vapor or gas form to the solid. The application of these sublimations are the sub-freezing of air, the formation of snow, the formation of frost on a leaf, and recovery of metallic anhydride from the non-condensable gas. There are two examples of this sublimation. The first example is sub-freezing of air phenomena. The water vapor changes directly to ice in solid form without first becoming a liquid. This is how snow forms in clouds and how the frost and hoarfrost form on the ground or other surfaces. The second desublimation example is the formation of frost on a leaf. This phenomena happens as the leaf becomes cool and causes water vapor in the air surrounding the leaf loses thermal energy to change into a solid form. The first one is the example of the sub-freezing air, whereas the water vapor from humid winter air deposits directly into a solid form. The crystalline frost pattern on a window without ever being liquid in the process. The second and the third picture is the examples of the formation of frost on a leaf.